स्टूडेंट्स, ये इस वीक का हमारा सैम्पलिंग टेक्निक का फर्स्ट लेक्चर है। क्लस्टर सैम्पलिंग फॉर प्रोपोर्शनल्स। Listen attentively. If the data is of qualitative type, and sampling unit may be classified into two categories according to any particular characteristics. The sampling unit having a particular characteristics in ith clusters are denoted by AI. Therefore, proportional of ith cluster is denoted by Pi is equal to AI over capital M, where capital M is the number of elements, small unit elements in a ith clusters, and the average of all cluster proportions selected in a sample is denoted by Pix. Sum of I varies from 1 to n, Pi divided by n. Thus, P is estimate of the population proportion. P is equal to capital P is equal to sum of I varies from 1 to capital N, Pi divided by capital N. The variance of small p is obtained by replacing yi by Pi in the equation in the formula variance of sampling distribution of mean y bar is equal to capital N minus small n divided by small n into capital N. Sum of I varies from 1 to capital N, yi minus y bar whole square divided by capital N minus 1. Now replace yi by Pi to obtain the variance of the sampling proportions. Therefore, capital N minus small n divided by small n into capital N, sum of I varies from 1 to capital N, Pi minus capital P whole square divided by capital N minus 1 is an which is an variance of a sample proportion. An unbiased estimate of this variance is variance of P is equal to capital N minus small n divided by n into capital N. I varies from 1 to small n, Pi minus P square divided by n minus 1, where Pi is the proportion in ith cluster and P is a proportions in whole sample. It may be noted that we cannot use by binomial theory if we find variance of small p, but must be applied formula for continuous variate to the Pi, because in a sample many clusters may selected in this sample and Pi is the different for each cluster, because P is the probability of the elements having characteristics AI. It will differ from cluster to cluster. हर cluster के अंदर वो एलिमेंट जो करेक्टरिस्टिक्स रखते होंगे हैविंग अ स्पेसिफिक करेक्टरिस्टिक्स AI, वो डिफ़र करेंगे, उनकी तादाद डिफ़र करेगी, लिहाजा उसी हिसाब से प्रोबेबिलिटी भी डिफ़र करेगी, प्रोपोर्शन दैट इज़ प्रोपोर्शन भी डिफ़र करेगा. देयरफॉर Pi is a continuous random variable in a sample, but in a simple random sampling Pi is a fixed quantity in वन सैम्पल. जबकि हम सिंपल रैंडम सैम्पलिंग के अंदर प्रोपोर्शन जो है वो आपके पास ith सैम्पल में या सैम्पल के अंदर वो सेम होगा. वेरियंस ऑफ कैपिटल P, वेरियंस ऑफ P इज इक्वल टू कैपिटल N माइनस स्मॉल n divided by n into capital N. I varies from 1 to capital N, Pi minus P whole square divided by capital N. If small n is a large, then capital N minus 1 is approximately equal to capital N, then variance of P is equal to capital N minus 1 into small n, and small n divided by small n into capital N square. ये जो है आपके पास ये वाला capital N minus 1, ये आपके पास रिप्लेस हो जाएगा कैपिटल N से, तो बाहर निकाल लेंगे इसको, ये आपके पास कैपिटल N बन जाएगा. ओके, I varies from 1 to capital N, Pi minus P whole square divided by n. It is without binary binomial so come here. If we take a simple random sample of small n into capital M elements, the variance of P is obtained by binomial distribution. Variance of the single unit variance of P through binomial distribution capital N minus small n into small n divided by small n into PQ divided by capital N minus 1. Variance of the whole unit n is small n and capital N both will be multiplied by m because each cluster having m elements. Therefore, variance of P through binomial theory is equal to capital N minus capital M minus small n into capital M divided by small n into capital M PQ divided by small n capital N into capital M minus 1. Now, if the sample is a large, जब sample large होगा तो capital N minus capital N into capital M minus 1 may be replaced by is approximately equal to capital N into capital M. Therefore, variance of P is equal to capital N minus small n divided by small n into PQ divided by small n capital N into M. The design effect factor. We can find the effect of this factor, design effect factor. Variance of P is equal to variance of binomial variance of P through binomial distribution, dividing both right hand side of the above equations, that is equation number 3 and equation number A, I think. Cancel out the similar terms and we have obtained this factor, and after that this shows that if def means design effect factor is less than 1, this value is, it means the value of this factor, where this factor is less than 1, then the design effect factor shows that the relative change in variance due to the use of the cluster. If design effect factor is less than 1, then we form the clusters. इट मीन्स अगर इसकी वैल्यू डेफ की वैल्यू लेस देन 1 होगी तो फिर तो क्लस्टर्स की ज़रूरत है. अगर आपके पास डेफ की डिज़ाइन इफेक्ट फैक्टर की वैल्यू ग्रेटर देन 0 होगी, देन वी नो नीड टू जनरेट क्लस्टर्स, वी फॉर्म क्लस्टर्स. फिर हम क्लस्टर सैम्पलिंग, इसका मतलब है नहीं यूज़ करेंगे, देन वी विल प्रेफर सिंपल रैंडम सैम्पलिंग. इफ द क्लस्टर साइज mi change, then the estimate pi is equal to p over sum of ai divided by sum of mi. Its variance is given approximately by the formula given below, this one. Capital M bar is equal to sum of I varies from 1 to n mi divided by n. If the sample is large, capital N minus 1 is approximately equal to capital N. Variance of P is equal to n into m divided by n m square m bar square. Sum of I varies from 1 to capital N mi square into pi minus p whole square. This will be the proportional of continuous ratio of equation C by equation B. Here ratio of equation C and by equation by B. To find here also the def mean design effect factor. After simplification, this factor we obtained that one. Okay students, try to understand.